Look at that. Look at how great that worked out. Okay. Isotopes. Man. Isotopes. Isotopes are atoms of the same element. Okay, maybe I wanted to spell SME. Okay, element. Same, there we go. That have differing numbers of neutrons. What's a neutron again? Carry me? It's a what? An atom with a negative charge? No, that's an ion. What? No charge. Okay, yeah, it is a subatomic particle with no charge. Okay? So subatomic particle with no charge, it can be found where in the atom? In the nucleus. Okay? So atoms of the same element that have differing numbers of neutrons. Neutrons are found in the nucleus. They have no charge. They have mass. Okay? So when we talk about isotopes in chemistry, so in chemistry we can do things. So let's take I don't know, element number. Let's just do iron, shall we? Oh, that's not what I want. I want this one. It's a little bit thicker, easier to see. Iron. Iron is number 26. Okay? Iron is number 26. Oh my gosh, that 6 is bad. Okay? It is generally has a mass of about 55. Okay? 55. So iron has some different isotopes though. Okay? So if we change the element, then we change the number of protons, right? Yes? Number of protons determines the element, okay? But the mass is determined by the number of protons plus the number of neutrons. So when we talk about different elements, so we're going to stick with iron here. So iron has 4 common isotopes. And they are iron 54, oh, that's not a 4, that's a 5. I know my numbers. And you're probably wondering why I'm not just using a text box. And that is because subscript in a text box is a pain. It's actually easier to... Dang it! Apparently I'm only able to draw 5s right now. For a second I thought, why is everyone laughing at me? And then I realized, wait a second, this is supposed to be a 4 again. Oh boy. 5, all right, here we go. You go down here, and then you go over, and then you go a big one down. There you go. Thank you, thank you. I'm here literally all the time. All right, 54, okay? And then we have iron 56. Gosh, freaking dang it. These fives, man, they're killing me. That's supposed to be an F. Now I'm mixing up my letters and my numbers. Oh, this is painful. This is the content that you come for, though. 56, 50, there's a 5, and then there's a 6. Got it. I got it. Okay. Iron 56. So what's the difference between these two atoms? What is the difference between these two atoms? The number of neutrons. Is the number of protons different? No, because they are both iron. Yes? Iron also has another common isotope. And if you think that I'm just getting this off the top of my head, you're wrong. I'm reading this off the Wikipedias. Iron 57. So iron 54 accounts for about 5% of the isotopes. Iron 56 accounts for 91%, and iron 57 accounts for 2.12%. Okay, we'll come back to why that's important later, but these are the 3 common isotopes of iron: 54, 56, 57. So when we're talking about elements, sometimes you'll hear chemists or physicists say, like, uranium-238, okay, versus uranium-240. Those are 2 isotopes of the same element, right? There are atoms that have 2 more neutrons than other atoms of the same element, okay? The important thing for you to understand when it comes to isotopes is how it affects the mass. Certain isotopes are also radioactive, okay? So let's talk about carbon-12 versus carbon-14. Okay? Carbon-12 and carbon-14 are, am I doing this wrong? Probably doing this wrong. Because my brain is completely just shattered right now. I knew it. I knew it, guys. Guys, I knew it. All right, I'm going to ask you to do something and you're going to be all really mad at me. Are you prepared? I need you to go back and erase all these. And I know, and no one is more mad about this than I am, because remember how hard I had to work to write that 4? Those don't go there. For some reason, I'm remembering wrong. They go, in chemistry, numbers go different places for elements, and I just put them in the wrong place. I put them in the place that indicates the number of those atoms. This is where you're supposed to put isotope numbers, okay? So you can write in your notes, Mr. Kroshaw's an idiot. In fact, I encourage you to do so. What was this one, 56, right? And 57. Hey, am I gonna get the numbers right on the first time this time? I sure am. Oh yeah. Whoop. And you're probably asking, why is it important where the numbers are? It's actually super important. And the fact that I neglected to think about that is pretty egregious. So you don't have to erase them. Just like make sure that from now on you put isotope numbers in the top left. I know, I'm the worst. Okay. So carbon 12, carbon 14. So what's different again between these two? Ryan? What's the difference between carbon 12 and carbon 14? Two numbers, okay? Well, there's a difference of 2 between these two numbers. I know that. What does that difference of 2 indicate? Not as a weaker or stronger isotope concentration, but the number of neutrons, okay? And this is not the number of neutrons, this is the mass of the atom. Mass? Oh yeah. Okay. So in carbon 12, it has 6 protons, 6p plus, and 6 neutrons, 6n. How many protons does carbon 14 have? How many protons? 6, right? Because it's the same element. 6p plus. That's a plus. And how many neutrons? 8. So generally I do my 8s by drawing 2 circles. I'm going to try the actual correct way. Here we go. Okay, that looks, hey, that's pretty good. 8 neutrons. Okay. Are we clear on how all that works? So the mass is here. So carbon 12, carbon 14, that indicates the mass of the atom, which the mass is the number of protons plus the number of neutrons. And you might be asking, well, how do I know the number of protons? It is just the atomic number, right? And that is something that you should know from last unit. The atomic number, parentheses. Cool? Sure. All right. That is that. I want you to pull out your laptops, go to the POGLE Isotopes activity that is due on Friday, and let's get started on it.